The Wittig reagent is a phosphorus ylide. So let's define what an ylide is. An ylide is a negatively charged carbon atom next to a positively charged heteroatom. You can have various different types of ylides because we have various different heteroatoms. So here's a few examples. Here's a phosphorus ylide. And we'll do something a little more complicated. You can have a bit of a complicated structure as long as you have somewhere the negatively charged carbon next to the positively charged heteroatom, in this case phosphorus. For a sulfur ylide, maybe we will have a carbon chain, 2 methyl groups on the sulfur, so 3 bonds on the sulfur. It will have a positive charge. If we have a negative charge on the neighboring carbon, that would be a sulfur ylide. And then let's do a nitrogen ylide. There's a positively charged nitrogen, and if you have a negative charge on the neighboring carbon, that would be a nitrogen ylide. One other thing about the resonance structures for these. So remember, nitrogen is in the same row as carbon, and those atoms can't expand their octet. This nitrogen has an octet. You can't draw another resonance structure where you have a double bond between the carbon and the nitrogen. That would exceed nitrogen's octet. But with phosphorus and even sulfur, those being in rows further down in the periodic table can have expanded octets. So even though right now, as shown, the phosphorus has 4 bonds and no lone pairs on it, we can draw a resonance structure moving those electrons between the carbon and the phosphorus. So if we do that, we get the other resonance structure. Likewise, in the sulfur ylide, the sulfur does have a lone pair. Right now it has an octet, but it can expand its octet. So we can draw another resonance structure for this one. It looks like that. Let's see how a phosphorus ylide is prepared. The starting material that you're going to start with is going to be an organohalide. So let's say we want an ylide with 3 carbons in it. So we want to use the 3-carbon organobromide here. You could also use the chloride or the iodide. Next, what we'll do is react this with triphenylphosphine, PPH3, and this neutral structure has a lone pair on the phosphorus. This will do effectively an SN2 reaction where the phosphorus attacks this carbon and you lose Br as a leaving group. So you get the triphenylphosphine with a positive charge attached because it was neutral and you donated its lone pair to form the bond. And you have the counter anion Br-. We don't yet have the negatively charged carbon because the neighboring carbon still has 2 hydrogen on it. So now what you can do is add a base to take one of those protons off. And these protons are especially acidic due to the neighboring positive charge. So we can add a base to this. There's various bases that can be used. A common base is just butyl lithium, and that's a carbon base. So if you see that, just break it up, lithium plus, butyl minus. That's a basic butyl group, so that will come in and take one of these protons off of the molecule, put a lone pair on the carbon, So now we have the negative charge, plus if you want to draw the byproducts, just get butane and lithium bromide. So here's our ylide, and you can draw either resonance structure.